All right, so now we're going to talk about the array list class, how to build one. And so fundamentally, of course, an array list is a list that's stored in an array. So what we have is an array, right? And in this array, we can store a number of items. When we instantiate our array object, we have to give it a size. Java cannot create an array of unknown size. Also, once you have an array in RAM, you cannot change its size. You cannot say, I want my array to be bigger, or I want my array to be smaller. You can't do that. I will show you how to make a dynamic array by tricking. It's not really a trick, you're not tricking anybody, but by making bigger and smaller arrays and moving the data over. So the array list in Java expands as you add items to it. Well, it's not the array actually getting bigger. What's happening is it's making a new array that's bigger and transferring the data into it. And I'll show you how to do that next week. But for now, we're going to stick to what's called a static array-based list. So this is an array list of a fixed size. So here's what we need. We need an array. So we're going to have to declare an array object in our class. And that reference will hold the array. We can call this whatever we want. My favorite word is to call it R. Doesn't really matter. It's often called list. That's a slightly more professional name, but that's fine. So we're going to have an array reference that stores an array. We are also going to need to know how big the array is. This we're going to store as a constant, okay, to start off with. We're going to store it as a constant, and we're going to call it capacity, right? So this is capacity. That's how much we can store. And then we need a third data item. The third data item is an int called size. This integer will tell us how many elements are in the list. So size will vary depending on how many items are actually in the list. Every time we insert, we will increment size. Every time we remove, we will decrement size. And that's how array lists work. Fundamentally, you increase from the top and you decrease, right, in size as you go. The easiest way to do this is to anchor the list at the top of the array, so element 0 is always the first element in the list. The last element in the list is always size -1. So if we have 2 elements in the list, then they are at position 0 and position 1. Okay? And we can determine if the list is full by comparing size and capacity. And if those are equal, then the list is full. We can check to see if it's empty to see if size is equal to 0. So some of these methods are super easy. So that's what we're going to do. When we insert, we will talk about how to make room for an element. For example, when you insert into position 5, if there are 20 elements, then you need to shift 15 of them down to make room. If you're removing from element 5, position 5, then you need to shift everything up 1 to remove the gap. And these mechanisms are required in array-based lists, because if you don't do that, then you'll have gaps and it won't be a list because the things won't be a sequence, right? If you have 5 elements, then a space where nothing is supposed to be, and then 3 more elements, that's not a list because it's not a single sequence. So as we insert and remove, we're going to make darn sure that we maintain the sequence of the list part of our array. Okay, so that's the concepts behind an array-based list. And now what I'm going to do is share my screen so that I can show you how to build one. And one of the first things I need to do is move Zoom off of the screen, and then I'm going to share. And then I'm going to pop up my chat, like I said before. All right. And so what I've already done in NetBeans is I have created a class called myArrayList. I called it myArrayList because I want to not call it ArrayList because that's already taken. Java already has an ArrayList class, and I don't want to name my thing the same thing as that. So the first thing I want to do is to declare the variables for the things that I need. And so I'm going to do public, okay, I can type, public static final int capacity, and I think I spelled that right. And let's just set it to 100 for right now. I might shorten it for example purposes, but I don't really care. And then I want a private, and I'm going to use an integer array just to make it simple. Ints are just such a clean data type for examples. So I'm going to do a private int array, right? And I'll call it R. And then we will build this in the constructor. That's a little bit cleaner. And then I'll do a private int size, which is how big the array is. Or I'm sorry, that's how big the list is, not the array. And then let's go ahead and pop in a constructor to get this to build. And I'm not going to take any items. I want to build this exactly how I want it to be built. I don't want somebody else to tell me what the size starts out as or what R starts out as. And oh, why did I use 100? One of the cardinal sins of using named constants is declaring a named constant and then not using it. That's kind of a boneheaded maneuver. Now, keep in mind that because it's an array-based list, I want to make the set of operations that we talked about before. I want to make insert, remove, get size, clear, and I'm going to go ahead with this one and make is full and is empty. All right, so I'm going to go ahead and make those items. And because I don't have a whole lot of time left in this particular time frame, I'm going to make the easy ones. So in order to find out if the list is empty, I can do a public Boolean is empty and return if size is equal to 0. If that's true, then the list is empty. So we get that almost for free. The same is true for is full. Public Boolean is full, right? All I need to do is return. I need to spell Boolean correctly. But all I need to do here is return if size is equal to capacity. Because if it is, then it's full. And the clearing the list, I don't have to do anything with this. clear list, right? You can call this anything, empty list, clear list, erase, reset. It's got all kinds of names, but I'll just call it clear list. And this one is super easy. All I have to do is set size equal to 0, and the list is empty. Even if the list has 95 items in it, I don't have to remove them from the array. All I have to do is say the size is 0, and the list is considered cleared at that point, because now all I can do is add items at the beginning. So those are the real simple items: setting it up with a constructor, determining if it's empty or full, or clearing the list. All these things are pretty straightforward. Now, what I'm going to do next, or what I'm going to do next time, I'm not going to do it this particular time, is we're going to do an insert at, right, which will insert an element at a given position, and then we will remove at. So we will remove an element at a given position. All right, and we'll save those for next time. So we will be doing these the next office hour, which is Monday. So, all right, so we've got this thing at least started. On Monday, I will clarify how to do probably both of these. We will probably be able to do both of these then. And so I will stop recording now. All right, I hope that was all very clear, and see you next time.